Let's take a look at the first type of new iLogic configurator that becomes a possibility with Inventor 2019. It's actually a recorded snapshot or snapshots of various states of an assembly. So if you've ever wanted to save different configurations of an assembly, you're in luck. This should be very powerful for you. So what I'm simply going to do is to place in a number of components. Now these components are pretty basic. What I'm trying to illustrate here is the concept of the type of configurators we can create with these new tools. And after placing these components, I'm going to just constrain a few of them using the normal constraint tools in Inventor. And then I might want to just sort of copy a few of these and constrain a few more of these. Okay, so this is my configuration number 1 here. In order to manage my configurations, I probably want a parameter to control those. So I'm going to go into my parameters and add a text parameter in here, which I'm going to call option. And this is going to be option A. I'm going to right click and make multi-value. I'm going to add option B and C into my parameter here and say OK. Of course, switching this won't do anything at the moment. I need my iLogic code to do that. But I've created, if I save this assembly, this is option A that I've created here. So how do I get that into a rule and record it? So let's right click in my rule here. Let's add a rule. I'm going to choose this, say options. And the most important thing to do in here is to say that this is a managed assembly. So I'm going to click on my manage component, new iLogic snippet here. I'm going to get rid of this helpful example code here and simply just say begin manage and end manage. And then all I need to do is to select the components that are going to be managed inside here and right click, and I'll choose this capture current state to capture everything, basically the components and the constraints and any color overrides in fact of these components. And I want this condition to be set if option is A. So it's added an awful lot of code in here, but I don't need to edit any of that. I can just simply say if option equals A, then this is the snapshot that I want. And then I'll just say else if option equals B, then this is the configuration that I haven't created yet. So I'm going to say save and run. And just to show you how this works, if I delete all these components, now if I run this, if I create a form and add that option parameter onto the form, if option equals A, iLogic's going to take care of that configuration for me. So B, nothing happens. A, it will recreate that snapshot of the assembly with all the components. Because I haven't put anything in B, there's no components in B at the moment. They're all deleted by the managed code there. So I'm going to say done. Let's change it to B now. And I can now create the assembly as I want it to appear in the B snapshot. Let's place a few of these components again. Again, they don't have to be the same component at all, but I'll just add in a few of these. And let's put in some color overrides, as this is also captured when we're recording it. Okay, and let's constrain these. And let's delete this last one. So if we want to save this configuration of the assembly, we can simply go into our rule and we can look at the scenario if option equals B, and we can capture all of the conditions of this assembly. So I'm going to right click on these 4 components and capture everything by clicking this last option, and you see it adds in quite a lot of code there. including the appearance overrides, and I'm going to just hit save and run. And now if I go to back to my form and switch between option A and option B, you see it will manage those components for me. And not only does it switch the components around, it will delete the components that are not required, which is even more powerful in some ways. So just to extend this concept briefly, if I had sub options, we can make it even more powerful this way. I can add a text parameter which is called sub option, and let's make that either 1, right click, multi-value, or 2. So now I've got sub options 1 and 2, and let's say for sub option 1 I want to place in a component, let's see, this manifold for instance, and constrain that perhaps like this, and say OK. So I'm going to capture this for sub option 1 by going to my rules, options. So if option equals A, then I'm going to say all that, and then I'm going to say as a sub option in there, if sub option here is equal to 1, then else and if. So I should be having all the indentation here, but I want to keep this as brief as possible. So I'm going to capture the condition of this manifold in here. There we are. And else the manifold does not exist. So I'm going to hit save here and hit close. And if I go into my form, right click edit, I'll add in my sub option here as well, say OK. Now if I bring my form up, I've got option A, there's B, so you see I'd need a sub option in the B option as well, but if I now switch to A, there's the manifold there, and if I switch to sub option 2, let's say OK, then the manifold will disappear. Let's bring it back and let's get rid of it. And of course these constraints are all retained and rebuilt as required by the managed iLogic code. So this is one idea for how you might use the new iLogic tools in 2019 to create different assembly configurations based on capturing snapshots of whether the components exist, what their color overrides are, what the constraints that have been applied to them are, and a few other things as well. Hope you enjoy this one. Let's move on to the next. Our second idea for iLogic configurator possibilities in Inventor 2019 is a modular assembly. By modular assembly, I mean an assembly where we're going to place components one by one, and we're going to attach them to various sensible attachment points, connector points on other components in the assembly to effectively allow us to create virtually any combination of components in different positions. It's an extremely flexible way of working and very scalable, and would be quite difficult to achieve using a previous version of Inventor. You'd have to be quite competent with the Inventor API to manage this. And the new iLogic function that all of this hinges on is the ability to assign names to different geometries in Inventor models. And this is just part files. If I hit File Open, and if I go and find the pipe part that we looked at before, what we've done here is inside the Geometry tab in iLogic, which is new in 2019, we've assigned names to different parts of the geometry. Let me just turn this on by right-clicking Labels Visibility, and here we can see that we've named each of these circular edges 1, 2, 3, 4, 5, 6 in turn. We can turn the visibility of these on and off, and let me just show you how we do this. Let's delete number 1 and let's reassign it. We just simply right click on an edge or a vertex or a face in the model, and then we have the assign name option, and I can just type in a name. I'm using the simplest possible names I can think of, 1 through 6, and there we are. We have a label. We can turn this on and off, and that geometry can now be recognized downstream in iLogic operations in assemblies where we need to constrain to a particular entity in the model, like this circular face for instance. Again, this works with planar faces, vertices as well. And now we've named this geometry, let's just save this part. We can use it when adding this part into an assembly by simply referring to it by name. So if I create a new an iLogic rule in here, if I want to create a constraint with this pipe 1, I can find my constraint options in here, and I'll just add an insert constraint by double clicking on it. And as long as I get these names correct, that's the name of the constraint, this is the name of the part, which is called pipe 1. Here's the name of the part I want to constrain it to, which is called, this is the name of the second part, which is called backplate 1. Now the name of the entity in the part is that named entity that I just created. So if I want to create it on named geometry 1, I can do that, and the named geometry on the backplate, that also has a bit of named geometry with the name of 1, and I can change a few of these other parameters in here as well. And if I just say save and run, that constraint has been created. It's created an insert constraint between those two with iLogic code using that named geometry. So using that principle of the method I just showed you here, what we could do is we could demonstrate a particular kind of modular assembly creation. So we won't look in detail at the code for this, but if I bring up this iLogic form which I've created, what this enables us to do by way of example is to get a file list from a particular Windows folder. This could be on your server, and this will allow me to pick which part I want to assemble. So let's pick pipe 2 for instance. This has got some named geometry in it, 1 through 6, like the other part did. If I hit add, this is using the iLogic snippets to add a component into the assembly, as we've seen in the other iLogic example. I can add as many of those as I want just by hitting that button, and that will add them in the default position. And then when I've got enough of these in the assembly, I can hit this constrain button, and when I do that, it's going to ask me using iLogic code to pick component 1, which I want to be this one. Then it's going to ask me to pick component 2, which I want to be this one. It's going to give me a default constraint between the two entities number 1. And what we've got in here is simply the option to select if I want to toggle between the different connection points, because of course in a modular assembly you might have several available sockets, several available options for how you want to connect parts together. So I've got numbers 1 through 7 here on this component, and numbers 1 through 6 for each of these pipes on this component here. So I can hit this component and I'll get the alternatives for that component, or I can hit this component here, and if you watch closely you'll see that component move around in terms of its direction. And so I can keep toggling until I get the exact solution that I want using those named entities, and then I can hit escape and accept that operation, and I've now got a relationship, an insert created between those two components. And then I can go and repeat myself, so I can say constrain again this component to that component for instance. I get the default, but then I can hit this button, let's just spin that around a bit, select the component I want to toggle the placement on, and you see the different options there. Let's say I'm happy with that one, so I'll hit escape to accept, and then I'll just go and constrain this last one here, this one to this one, and then I can again hit this to toggle which direction I want, which connector I want to connect to, and this one to toggle that, and then hit escape to cancel. Let's add in one other component here, so I'm going to choose a different component, add this one, let's add another one of these, and then I'm going to say constrain this component to here. There's my default, and I can just toggle between them until I get the precise option that I want, which is that one. Escape, accept, one last one, this one to here, component 1, component 2, and just toggle until I get the precise option that I want, which in this case is that one there. And then I can hit escape to cancel or to accept. So you can see if we name the connectors or the named entities on our library components 1 through 6 or 1 through 10 or whatever it is, we should be able to effectively allow an infinite variety of assemblies when we're connecting them together using some kind of toggle mechanism like we have here. What I've done in this example is I've said that an entity number 1 can connect to a number 4, or number 3 to a number 2, or any number to any number. But what you might want to think about is only allowing number 1s to connect to number 1s, or A's to A's, or B's to B's, or whatever it is, to allow perhaps more control or more intelligence for these kind of modular assemblies. And I can say that this iLogic code to toggle between all of the available options for connectors there's only about 45 lines of code, and then that can be generic code that can be used for any assembly, whereas this would probably have been hundreds of lines of code previously with the Inventor API. Okay, I hope you enjoy this one of modular placement of components. Our third idea to consider for iLogic configurable assemblies in Inventor 2019 is adaptive placement of components in an assembly. Now, traditionally in Inventor since 2010, this has been handled by a tool called iCopy, which allows point and place placement of stretchable, adaptable components in an assembly. But the method of using the named entities that we saw in the last example allows the possibility of making this much easier than having to publish an iCopy template as before. So what we've got here is we've simply got a panel part file. Again, this is only for part files at present. You'd have to use a multi-body part file or something like that. And we've created 4 named entities in here, which are simply the corner vertexes. So again, I can do this just by right-clicking assign name on a vertex, and these are the 4 vertices I want to use to place this into an assembly. And I've made this extrusion adaptive I should say, so that it can stretch to suit when it's placed into an assembly. So if I close this part and open up a framework part that I've created, this is 2 walls that I want to place those panels on, and I've simply got work points in place for where these panels need to be attached. Please do have a chat with excitech if you want to learn how you can intelligently create these frameworks of points to be attaching items in your Inventor assemblies. But we've got these points here ready to go for now. So let's bring up our form here, our iLogic form. Again, we're not going to be looking under the bonnet at the code for this. This is just to hopefully stimulate your imagination on what can be done. So just as before, we've got a file list of components we could add. This is coming straight from a folder. Let's choose that panel part that we saw before. I can hit add, and I can add as many of these sort of empty or ready to go panels as I want into the assembly. Okay, and once I've added a few of those, again I'm just doing this one by one, I'm then going to say attach to points, and this is going to run an iLogic rule which is going to enable me to pick the first component to attach and then just pick attachment points 1 through 4. You can see the prompt there on my mouse, and I'll pick point 1 here, point 2, point 3, point 4, and that's attached that one. And I can go and repeat myself. Let's just, before I do that, let's just hit done and see what we've created. We've simply just used those named points to create a mate between point 1, point 2, point 3, point 4 that you can see here. And these mates can be deleted or edited the same as any other mates. So let's just see that once more. I've already added these components in. I'm going to say attach to points, and of course if I pick this component here, because these components are adaptive, this is where it becomes so clever. We can pick to attach a different size panel Let's choose another different size here, so hopefully you can see these panels are clearly different sizes and shapes. Let's do a couple of extra ones. Let's go across 2 panels here, this one here, and let's just attach the final panel here. Let's place it on a different face. Okay, so hopefully you can see how powerful this could be, with really quickly allowing you to point and place in an assembly as an alternative to the more traditional but more complex iCopy method in Inventor. And I have to say as well, the code for this place parts adaptively is only about 25 lines of iLogic code in this case, and it's mostly using the constrain snippet, which I'll show you here. In our new constraint options, we've got the option to add a mate, and we'll simply be adding a mate between 2 points in the assembly, 1 point in the panel and another point in the other part. So really nice and straightforward, very powerful. Hope you enjoyed this one. Our fourth idea for new ways of creating iLogic assemblies in Inventor 2019 is another adaptive placement method. In the last example, we looked at placing a single adaptive component one at a time, but these new tools do give us the option to automate that further by placing multiple components. Now, just to give you a bit of background on this idea, what we've done is inside Revit, if I switch over to Autodesk Revit, we've got a layout created of panels that are being attached to a wall. And what we've done is we've used a tool called Dynamo in Revit to extract the XYZ positions of those points, and we've then imported those XYZ positions of points into Inventor as work points. Now we've got these named work points inside Inventor, we can use a iLogic routine to automate the process that we did single panel at a time in the last example. We can add as many panels as we want based on how many named points there are in the model. So if I simply just run this rule, exactly the same thing is happening as before. We're adding each component with 4 mates, 4 mate constraints, but they're simply being added sequentially based on the sequentially numbered named work points inside the target part. And you can see how powerful this could be for effectively matching a layout from Revit or building up any kind of adaptive layout using some fairly simple iLogic code that's now been made possible in Inventor 2019. Hope you find this one very useful. Let's move on to the next. Our fifth suggested method for how this iLogic capabilities introduced in Inventor 2019 could be used is a slightly more whimsical one. I've called it Computational Placement, and this may be relevant to less companies, but could be extremely powerful if it is relevant for the products that you make. It's simply where you're introducing a number of loops into some iLogic code in order to effectively compute the placement of multiple components based on some user input. So let me show you what I mean by this. If I bring up our iLogic form, remember we've got these named entities on these circular edges for these pipes, and we're simply going to be adding various patterns or arrangements or structures of different components based on various user inputs here, and that's all based on the ability in iLogic now to add a constraint to a named entity. So if I change a parameter here that defines the pipe direction, every time I change that, it's going to automatically compute a new arrangement for this assembly. Let's say this is almost random directions just to illustrate what can be done, and you see I've also got the option of increasing the row quantity here. So if I change that to 3, you see that more components are added. If I change it to 1, less components are added, or 2. If I change it to 4, again more components. Excuse me, let's change it to 4 here. More components are added. If I change it to 5, we've got more components being added here, and with this we've got virtually an infinite number, almost, with more options we could build up almost an infinite number of different arrangements. So let's look at the different directions here. Again, this is random directions, and if I increase the width of the assembly, then it will compute and add more rows, and that might also adjust the size of the assembly. So you can see here, if I increase it, so I've now got 4 rows, you can see the components are changing size here as well. Okay, and now I've got larger arrangement. I can choose different directions now, and it will rebuild based on the options I've selected. Okay, so you can see that if you input a sensible collection of rules as to which components should be added, this could be an extremely powerful way of building up certain types of assemblies. Okay, I hope you find this one interesting as well. Thanks a lot. Let's look briefly at an improvement in Inventor 2019 which might not seem too exciting unless you've had real issues with this in the past. This is changing and customizing the color scheme. What do I mean by this? Well, I mean the color that Inventor shows when you select something or hover over something. I mean the color that you get that lines are when you're sketching. For instance, an unconstrained line is this color, and a constrained line, if I lock it, is this color. If I want to make changes to this, perhaps because of color blindness or just general ease of use, this is now possible with going outside the standard range of color settings that normally ship with Inventor. So if I go to Tools, Application Options and go into the Colors tab, these are your traditional color schemes, but you can edit them now. So I can hit Customize Schemes, and a nice easy one I can do in here is change the selection color. You see the amount of changes you can make here. This is both powerful and dangerous because you could make Inventor quite difficult to navigate if you make too many changes in here with all these subtle changes between colors. Also, other people using your Inventor might get pretty confused if you make too many changes, but let's just illustrate this. If I change my highlight color to red and change my translucency to, say, halfway, for instance, and say OK and apply. Now if I highlight something, it will, excuse me, let's finish this sketch. If I hover over something, it now appears red, which is quite oppressive really, but illustrates the level of control that you can have. Let's head back into this sketch. If I want to make a change to my sketch line colors, again this option is available in here. I'm going to say Customize Schemes, and inside a sketch the important ones in here are full constrained curve and an under constrained curve here. So if I want under constrained curves to appear, again let's just say red for really easy recognizing. If I say OK to that and say OK and OK, it's very clear to me if any curves in my sketch are not fully constrained and are still jelly curves, as we like to say. So pretty powerful. Use these with caution, but a lot more flexibility has been added. Sharing a 3D view of your design has become easier in Inventor 2019. Previously you had shared views which could be accessed using an add-in which had to be made available, and it was accessed down in the bottom right hand here. It's now available in the File menu. I can hit File, Share, and what this will do is this will convert my Inventor model to a web viewable format and upload it to a URL which I can share with anyone. They don't need to be a CAD user. They can simply view it in their web browser of choice, and they can use all the Autodesk viewer tools in there, such as exploding the assembly to view it properly. They can view component names and properties if you enable them. because of course you may want to protect your company intellectual property, and they can also mark up the design. So anyone with an Autodesk ID, a login, they don't need CAD, they can view the web browser viewable file, and they can type in their comments and mark up the design, and you'll be able to see it when you visit the same URL. So I'm going to just hit, let's call this a particular a name for the shared view, and when I hit share I get a progress bar. It's got some converting to do, which it uses your local resources to do, so Inventor will be called into in the background to create this web viewable format. Depending on the size of the design and your web connection, you'll get an email that will come through to your Autodesk named email account, and you'll also get this notification appearing in the bottom right of your Inventor screen when it's complete. And once it is complete, the URL will look much like this. Make sure you set the top view in your view cube to be the view you actually want to be top in the viewer by right clicking on it, otherwise it will come through in the wrong orientation, although you can reset it up here. Just make it easier for other people if they don't need to do that. And in here you can use the normal Autodesk viewer tools, which are being updated all the time. We can view the model browser here. We can view any properties of the model. In this case I've got a few properties here. Let's close that. We can do a first person walkthrough using the arrows on our keyboard. And we can also do some exploding of the design. If I hit the explode tool, we can pull it apart and put it back together again. Some pretty powerful tools, and you can navigate through in an exploded state as well. Okay, and this tool, as I said, is being improved all the time by Autodesk, so it's a pretty powerful option here.